Hiya 13s, we're going to look at special triangles, and these are the special triangles that we're going to look at. Now before we get in there, I want to talk briefly about radians. So these radian measures that we have here, 30 is the same as pi over 6, 45 is pi over 4, and 60 is pi over 3. And so when we look at these triangles here, they're in radians, but we could also write those angles in degrees. So we could say that this one here is 30 degrees and this one here is 60, and we could say that these ones here are 45 and 45. Okay, so we're going to work out exact values for all of our functions based on these triangles. And so sine, when we're 30, we'd be working with this triangle here, and it's opposite over hypotenuse, so that would be a half. Cos is adjacent over hypotenuse, so that would be root 3 over 2, and tan is opposite over adjacent, so that would be 1 over root 3. For 45, we're onto that other triangle, and so sine would be opposite over hypotenuse, so 1 over root 2, and cosine will be exactly the same, and tan would be 1 over 1, which is 1. Okay, for 60 degrees, we're back to our other triangle. And so sine, because we're changing to this angle here, opposite would now be this one, and so sine would be root 3 over 2, and cosine would be 1 over 2, and tan would be root 3. And so you can see they're just all the reciprocals of when we're at 30 degrees. Okay, so applying these exact values, this one here says use the trig values from the special triangles to determine the exact value of sine 15. So if we think about how we can get to 15 using those angles, 15 is equal to 45 minus 30. Okay, or we could write it as 60 minus 45. So either of those combinations could work. So what we want to work out is sine 45 minus sine 30. Minus angle of the angle 30. So we're going to use the double angle formula here, and so the compound angle formula. So that's this top one here. So sine A cos B, cos A sine B. So let's write that out. So that's going to be sine 45 times cos 30 minus, make sure we get it right, cos 45 sine 30. And we're going to substitute in these exact values from our table up here, and so we're going to have sine 45, which is 1 over root 2, times cos 30, which is root 3 over 2, minus cos 45, which is 1 over root 2, times sine 30, which is a half. So let's work these out. So that will be root 3 over 2 root 2 minus 1 over 2 root 2. So let's go a line per part of the fraction. So there will be root 3 minus 1 over 2 root 2. So let's rationalise the denominator, times top and bottom by root 2. And so that will be root 6 minus root 2 all over 4. Okay, and that's how we can write that as an exact value. Just looking at this fraction, we could possibly also write it as root 2 times root 3 minus 1 over 4, and that would be acceptable as well. Okay, so have a go at this exercise here. For those of you who use my old textbook, I've had to put it in because it's not in the old textbook, but yeah, have a go at 6.09.